Right, so we've got here the states of matter. So here you've got solid, liquid, gas. So if it goes from solid to liquid in this direction, it's called melting. From liquid to gas is called boiling. And then if you go backwards from gas into liquid form is called condensing. And if you go from liquid to solid, it's called freezing. Now if you go from solid straight to gas, it's called sublimation. Sublimation. Right, if you go backwards, there's two words that they use for when you're going that way. It's called desublimation. They accept that, and deposition. But that's rare that comes up. So X is boiling, Y is condensing, and Z is freezing. Right. Which statement best describes the movement of particles? So it's this bit here, in a gas. So they don't vibrate, so it's not that. Particles slide past one another. No, that's in a liquid. Particles do not move at all. No, that's not true. So that just leaves C. Okay. So here you've got a beaker. This measures the thermometer. You've got something to stir, you've got the liquid, you've got the heat, you've got the solid that's going to melt, and you've got the gauze, or well, right, give the name. Right, okay, that's a thermometer. A thermometer is used to measure the temperature of something. Temperature. And you use the stirrer because look, if let's go that way. So if all the heat is concentrated here, all the energy that you've put in, right, and you're measuring the temperature here, it'll give you a false reading. So what you do is you mix it so the temperature is evenly distributed. Then you'll get a truer reading. Right. The solid melts at 140. Water is not suitable to use this experiment. So what they were doing, let's get rid of that. Right. What they're saying is that this here is water. This will start boiling off at 100 degrees Celsius. But this melts, this solid Q melts at 140 degrees Celsius. So this will all have evaporated before that melts. So that's why it's not suitable, because it has a, you can say water boils at 100 degrees Celsius. Yeah, and that'll boil off before it's melted. So just why the liquid in the beaker needs to be stirred constantly. Right, to distribute the heat evenly, right, to keep the liquid at an even temperature. Right, you got solid, liquid, gas. Now if you noticed here, have you noticed this sort of like displayed in nice rows, there's no gaps? That's a solid. So if they ask you to draw that, you have to draw it like this. If you notice here that really what this is a bit poor, because look, it should be touching that. There should be no gaps anywhere. Ideally it should be like this, because when they ask you to draw it, they say make sure that there's no gaps. They can slide past each other, right, but there should be no gaps unless it's ready to boil. And then you've got gas, which is just randomly everywhere. So it says complete the right. Another thing, 1 2 3 4 5 6, they want at least at least 6 particles. So bear that in mind. Which statement is correct about the movements? Right. Which statement is correct about the movement or arrangement of molecules of this substance? Yeah. They move randomly. Okay, they remove random. No, they don't. They are fixed. They just vibrate. They move randomly in a liquid state. Yeah. They are arranged in fixed positions. No, they're not. And we're just going through. They are arranged in fixed positions, and no, definitely not. So it was B. The reason we read through those is just to let you know. Right, which term is used for changing from a solid to a liquid? It's gonna be melting. Yeah. Right, let's keep moving on. Right, here you've got your bung. Here you've got your conical flask. What is occurring in the flask? Boiling, condensing, and evaporating. So it's definitely not freezing, because that's liquid. Freezing and melting, no. Right, there's no heat, there's nothing here to, it just says water vapor and air. So there's no boiling going on, and it's just to do with, so what's happening? Let me get this right. So from here, there's some evaporation taking place. So you end up with that there. And then what'll happen is some of that will condense and fall back in, and you'll end up with an equilibrium. And it depends on sort of the conditions, but that's what's going on. So you've got evaporation, and when it goes back, condensation or condensing. Right, which formula represents a substance not present in the flask? So look, basically what they've given you, they've given you a hint. Right, you've got water, so you've got water in there as a gas, as a vapor, liquid. Now we've got to decide, because air is nitrogen, oxygen, argon, and CO2 and other stuff here, right? In this case, it's water vapor. Right, so we know it's not them two. So now we need to decide, is it nitrogen gas or liquid? And nitrogen to be at a liquid is going to be a minus temperature, minus in the minuses. So the only thing that's left is, oh, sorry, it says not. Whoa, you've got to read the question. They've even highlighted it here. They've said, let me write that down. Look, they've even done that for us. And if you switch off for a second, you're going to do that. So it's not. So this is not in there. So okay. So I got distracted with that and I lost it. So you've got to be careful. Very careful. Right, okay. You've got water droplets, water vapor, liquid in there, kettle, and it's boiling it. As the water vapor cools, it turns into droplets. Right, it changes from liquid, from water vapor to liquid. Right. I almost said it's condensing. Condensing. Or condensation. Right, it can't be boiling. Boiling is occurring from here to turn it into a gas there. Evaporation, it's not that. That can occur without any heat. That's boiling at the moment. And sublimation is solid to gas, it's not that. And the boiling part is up there. So the only thing that's going on from water vapor, it's going from gas to liquid. Right, okay. Right, these are interesting ones. Just learn how to do these actually. Right, describe what happens when water vapor cools to form liquid. Your answer should include the change in energy, arrangement, and movement. So look, what they've done is they've split this question up for you. Sometimes, and the way the questions are going, they're going to just say, do that. And then they won't give you spaces to write in, so you've got to put them sentences together, yeah? So the particles lose energy. Right, so that's what's happened. They move closer together. Move closer together. Energy, arrangement, and movement. Right, then they start moving. Well, they start moving less freely. The particles move less freely. So what's happening is with the gas, they're moving freely randomly. With the liquid, they slide past each other in a random way, but it's less free than a gas. Right. Substances can be elements, compounds, or mixtures. This is a good point to write down the definitions actually. So elements are substances that can't be split into anything simpler by chemical means. That is what an element is. Element is right. So compound. Compounds are formed. Compounds are formed when two or more elements chemically combine. Right? It's always in a fixed proportion. So, for example, you've got sodium chloride, you've got magnesium chloride. So, you've got one sodium, one chlorine, one magnesium, two chlorines, and so on. Right, the last one is a mixture. So, a mixture consists of lots of different various substances that are mixed together but no chemical reaction occurs. Right, they can be separated by chemical means. There you go. Right. Which of these is the correct symbol for an element? Right. That's a molecule. That's a compound. That's a compound. So the only one is there. Which of these substances is a compound? Right. Hydrogen's an element. Oxygen is a molecule. Right? These are elements in molecular form, so that'll be H2 and O2. And water is H2O. And air, is really, you can class it as a mixture. So the only one here that is a compound and not a pure element is water. Which of these methods is used to obtain water from a mixture containing salt and water? So what you've got water here. Let me just go through that. Well, you've got water here. You've got your salt here. Right, let me try to put these words in. So this is the solvent. This is the liquid that's going to dissolve the thing. This is the solute. That's the thing that you're going to dissolve. When you've mixed, get this right. When you've mixed this solute in the solvent, let's just change color. Right, this, that's not very good, is it? That wouldn't be a good color either. Right, this bit here is the solution. Now, to separate them two, what I do is I heat it and I just evaporate off the water, and that will leave behind, when all the water's evaporated, salt crystals. Right, and that's simple distillation. It's not filtering. Filtering won't help. Crystallization won't help. Titration won't help. Right, let's move on. Oh, chromatography. Right, there you go. That's a good definition. Paper chromatography is used to separate dyes present in some inks. So you've got actually everything's labeled up. That's the solvent front. That's the baseline. Have you noticed that the solvent line here is below the baseline and below the inks? That's how you don't spoil it. That's the lid. To stop, I don't know, to stop everything evaporating off and what do you call? Yeah, what you have to do as well is before you start, leave this in here for a short while, I suppose a few minutes, half an hour, to let any solvent to evaporate and reach an equilibrium point. So you've got the solvent evaporated and it's an equilibrium point, right? What do we need to do? Right, okay, state why the solvent level should not be above the baseline. Right, because it will interfere with the results. That's the problem. Right, this is to stop the ink or the spots dissolving in the solvent. Okay, explain which dye is present in one of the inks A, B, C, or D is also present in P. So P, you've got this dye here and this dye here. Now, so if you look along that line, you can see that is also present. So which one is that? Ink B. So it's a two marker, so you'll say ink B, right, because both inks have a spot at the same height. There you go. Explain why ink D does not move. So that stayed there, that one there. Because it doesn't dissolve, it's not soluble. It is insoluble in the solvent. Right, let's keep going. Ew, retardation factor. Right, let's handle this then. So the retardation factor is the distance moved by the dye divided by the distance moved by the solvent. So if we go up here, remove all this. Right, if I measure, let's say from here, I want to check out the retardation factor of this. So that there is the distance of the dye. And then I've got the distance from here all the way to there. That's the distance the solvent has moved. I mean, really, it should be that, but that's the baseline that they work off. Yeah, so don't mix the two. Right. So we need to, well, you'd have to measure that, and I haven't got a ruler to measure that. And then you just divide the two. So distance moved by the solvent is 49. So they're saying distance moved by the solvent is 49. And then what you do is you measure the distance moved by the dye in ink A. Right, okay, I looked at P, so let's look at A. So let's get rid of that. It will be A. So you'd measure this. That's 49. Let's go for this as 25. So that's 25. All you do is you do 25 divided by 49 equals the answer. Done. Right. Okay. The diagram shows an experiment to demonstrate diffusion. So you've got cotton wool soaked in ammonia. I'm going to highlight this. NH3 is ammonia. NH4 plus is ammonium. This is an ion and this is a molecule. Right. There you go. The word equation for the reaction is ammonia plus hydrogen chloride gives ammonium chloride. This is another one that you need to know as well. Look, hydrogen chloride, when it's not mixed in water, is called hydrogen chloride. When you just say, let's just say it's a gas and it's evaporating away, yeah. Hydrogen chloride, when it's mixed with water, we know it as hydrochloric acid, and that aqueous means it's in water. It's mixed with water. Again, these are important, so you can put these on a the good facts to recall, actually, these. Right. It gives ammonium chloride. Right. Draw a circle on each of the two state symbols that are included in the chemical reaction. So you've got a ammonium chloride is a solid. So them vapors go across, and what happens is they meet together and form a solid. So you're going to end up with a solid and two gaseous states, because the vapor that's going across, right, you could argue that's soaked in liquid ammonium, but that's not what they want. Okay. Right. Remember what we said with this. This is where you got to be careful. Just make sure you draw them carefully. Slowly. Right, so then the touching. There's no gaps. Because the example that they gave was not brilliant. Right, with the liquid there were gaps. There's no gaps in this one, but in the previous one there was. Right. And there. And there. There. And there. Should we squeeze one more in here? And there you go. Right. What they expected. So they want a minimum of 2 rows. 1 row, 2 row. You can do more if you want. You can carry on, but at least 2. Right, which row describes an arrangement of in a solid? The regular and vibrating. Which word describes water changing from liquid to solid? So that will be simply freezing. And remember what we said, if you go straight from solid to gas, it's called sublimation. Wait, come on. Sublimation. Right. You're going from a solid to a gas. Yeah, and that is called sublimation. They've not given you any list to choose off, so it's good to know these words. What is the name of H2O? And as a liquid and as a gas, you can have water vapor or steam. See, these gaps are no good, really. Right. So what we need to do, use the letters X, Y, Z to give the starting and finishing states. Solid iodine goes from Z. To solid iodine to iodine gas, that's X. Molten iron, that's liquid iron to solid iron. Liquid will go from Y to Z. Ethene to polythene. Ethene is a hydrocarbon, right? Alkene. So that will be a gas. And then, do you know when you're doing hydrocarbons and fractional distillation? And it goes to polythene. Polythene is a solid. Make bags out of it. So that's all they're saying is link it back to that. Which of these changes takes place when solid goes to gas? So when you go from solid to gas, from solid straight to gas, we said it was sublimation. Sublimation. So that's that there. Right. Right. You've got solid, liquid, gas. We've got to use these words. So if you go from solid to liquid, you are going to be melting. If you go from liquid to gas, okay, they've not put boiling, so evaporation is the next one. Because they didn't put boiling, when you go from liquid to gas, another way of doing that is through evaporation, and then you're going from solid, where are we, solid, from solid back to straight to gas, it's called sublimation. Sublimation. And remember what we said about that, it's desublimation, the other way, sublimation. Oh, wow. Sublimation or deposition. Deposition. Okay. Right, 3 marker. we need to describe the arrangement and movement of particles in a gas. Right, first of all, are they regular or irregular? The arrangement of particles is irregular. Right, the next thing is there are large gaps, they are very far apart between particles. There is, right, okay, there is random movement and they move very quickly. Right, okay, that's that done. Right, okay, we'll try the next one soon.